In this video, we're going to discuss about the cash futures convergence that can happen in the derivatives market, and that's our final section of Unit 2. In cash futures convergence, we need to remember that the future price and the price of the future, if you remember, we've gone through this, is going to be calculated as the spot price into 1 plus the rate of return that is expected raised to the power t, and this has to hold, t being the number of days to expiry of the contract, right, or days to maturity of the contract. R is the daily interest rate here, right? Remember, daily interest rate, so we're going to kind of divide it, and we're going to use so this is useful in a discrete market scenario, but might have some approximations that we are going to use in this formula to understand what we are trying to do. So those approximations aside, we're going to kind of look at what's the data point and how we're going to look at it, and what we are going to basically look is the convergence. So logically, as the future price becomes the spot price into 1 plus R and this t becomes 0, then the future price should become the spot price. There shouldn't be any difference in these two, right? So that's what we are trying to plot, and that's what we will plot using a chart as we go along, right? So let's go to the Excel file and let's put in the future price. Let's put in the spot price. Let's first calculate the implied interest rate using these two data points, right? So we're going to first find these out. Then we're going to say days to expiry, and that can be calculated as the date, the expiry date, and we can calculate how many days to expiry are there. We can find out what's going to be the spot price, and we can find the spot price by using a randomly generated number, something that we have seen in the past. So we can put a spot return here, and then we can look at the future price. Just to kind of make things simpler, I'm going to put these two here, and I'm going to calculate the future price here, right? Now to calculate the spot return, we will need two more things: the mean return and the standard deviation of the underlying market daily data. Daily data is what we'll need, right? Let's go to the NSE website, and on the NSE website you find that your NSE underlying value, Nifty underlying value, is 9108, and we're going to use the next month future. That's going to be 27th of April, and that last price was 9143.55, right? So we are going to put these data points. Future price is 9143, spot price is 9108. What is the implied interest rate, right? What is the expiry date? Expiry date is 27th April 2017, and this price is as on date. This price is as on the date. We can go and check what date this price is as on March 24th, right? So we're going to put March 24th 17, right? So what were the days to expiry? Can I find the days to expiry? So that's equal to this minus this. 34 days to expiry was what was left till then, right? Or I can start with this number and say 34 days to expiry is what we have, is A minus B, right? Future price is given to us, spot price is given to us, right? Now we're going to project this as we go along, and we'll just make life simpler. We'll not use we can actually figure out what's going to be the Saturdays and Sundays and then try and work that, but we're using discrete pricing changes and not any continuous changes, right? What the equation would say is that 9143 is equals to 9108 into 1 plus R raised to the power 34, right? So we have to take 9143 by 9108, 1 by 43 minus 1. That's going to give me the daily return. And then if I multiply this with 365 approximately, that's going to give me my annualized return effectively, right? Approximate data is what we are looking at. So let's calculate the implied interest rate. That's equal to 9143 divided by 9108 raised to the power 1 by 34 minus 1. That's my implied interest rate, and I can put all this in the bracket and multiply this with 365. That's my daily implied interest rate. Right now, this may or may not be correct, but that's what the data gives us. This could be lower than what the market interest rate would be, is because the future also incorporates the fact that there could be some dividend. So the future price is actually not just spot price, but spot price minus dividends into 1 plus r raised to the power t. Right now, that dividend data is not directly available. We can calculate, because when the dividend goes out, the spot price will fall, and hence the future price already incorporates that, right? So effectively what we are saying is that that includes, and possibly because of that, the implied rate is lower, right? Now I will again this is the yearly rate. We can do this, that's the daily rate, and this into 365 is the yearly rate. That's what we have done. Let's add a couple of decimal points and try and arrive at the numbers for subsequent data points. Now, let's assume for simplicity's sake that the annualized return is 15%. This is the annual data, and the annualized standard deviation is, let's say, 15% as well. So what should be the daily return and daily standard deviation? Remember, annual standard deviation comes from daily into square root of 250. So if I take this and divide it by square root of 250, we should get the daily standard deviation, right? Daily mean annual return is 1 plus r raised to the power 250, because there are 250 trading days, and that's equal to 1 plus 15%. So here I'm going to take 1 plus 15% raised to the power 1 by 250 minus 1, and that's my daily return. So that's my daily return. I can back calculate and say this plus 1 raised to the power 250 and this minus 1 gives me exactly 15% return, right? That's my mean, that's my standard deviation. Can I anticipate a return using my norm inverse function? Remember, probability has to be a random number. My mean is 0.06. My standard deviation is given here. Close bracket. That's the spot return for the next day. If that's the spot return for the next day, my spot price should become this into 1 plus the return. And consequently, my future price should become this into 1 plus the rate of implied interest rate, freeze this, raised to the power number of days to expiry, whatever that number of days to expiry are, right? And that should be my data point. Obviously at this point it shows it as the same because we have not incorporated the fact that this number would be, let's say, 33 days. And the moment you put 33 days, depending on what the spot value is, the next day you see the future value go up. And I will just link this to -1, and we will just take this down all the way up to 1 day, and finally a 0 day scenario, right? That's what we do. Let's go ahead and put all the data points in. I'm going to freeze the pane so we find it easier to kind of scroll through and see what is happening. And let's actually not freeze them there, unfreeze, let's freeze them here. So We can go down. All the data is kind of plugged in. All I need to do is, so there's some error that we have done, and the error is that we've not frozen these two. We have to freeze the normal data points, and then we can extend this. It works fine. So every day there is a spot return which we have projected based on the numbers that we have available, and we will find that as we go along, the final day, the prices of the spot and the future will converge. They will become the same. So you can do it as many times as you want. I can keep pressing F9, but you will find that the final day, the spot and the future price will be exactly the same, right? Let's plot a chart around this. So we're going to plot a chart with this data. I'm going to use this. I'm going to go to insert a chart, and that's going to be a line chart. In this, we have the spot price, we have the future price. What I don't need is the days to expiry, because that's going to be my x-axis. And in my x-axis, I'm going to kind of format the axis. Let's do that later. Let's first select data. My x horizontal axis label range is this entire set from 34 onwards till down. So that's my horizontal axis. Click on OK. Let's go to view and let's remove the freeze pane so we see the chart clearly, right? That's what we see, and you see that at the end it all converges to the same value. What I can do is I can make this a little bit better looking, so I can go down and make it a smooth line, and similarly I can select the orange segment and make it a smooth line, so it becomes more curvy in nature and we are able to spot that slightly better. We can also format the axis to have the minimum and maximum values fixed at, let's say, 8800 and 9400. Some of it goes out obviously, so 9500 will probably be better. And on the downside, we can probably use 8900 and see how this works. You see, on the final day, they will converge. On the final day, they will converge, come what may, the scenario may be. So effectively, that is a classic case of the spot futures convergence. We've used concepts of normal inverse function. We found the daily and average, daily standard deviation and daily mean return for the Nifty index. If we reduce this, then obviously things change a little bit and the curve changes a little bit. If we increase this, then probably the curve changes a little bit as well. So that's basically what our cash futures arbitrage means. In this case, obviously, the levels have to be good enough to take care of your movements above the entire scenario. So you do need slightly higher levels, because in some iterations it might just go beyond, right? That's your cash futures arbitrage. That's it in this particular video. Thank you.